the binomial series. We're going to find a Maclaurin series for f of x equal 1 plus x quantity to the k, where k is any real number. So first of all, we need to look at that function at 0, and that's going to be 1. We need to take the derivative of that function, so power rule, power out in front, decrease the power by 1, and evaluate that at 0, and that would be k. We continue doing that. The second derivative, another power out in front, decrease the power by 1, and we could evaluate that at 0 and get k times k minus 1. And we could continue doing that. Here's the third derivative, and we see the pattern. So the nth derivative would be moving these powers of k out in front, and we would get up to the nth time, which would give us k minus n plus 1, and then here is our 1 plus x to the k minus n. And then if we evaluated that at 0, we would get this. So let's use that and express this Maclaurin series then. And here is what we found for the coefficients. We want Maclaurin, so we're centering it at 0, and so this would just be x to the n here. This is called the binomial series because we are expanding a binomial, a two-termed polynomial here. Now, for what values of x does this converge? Well, let's go ahead and take this and use the ratio test. So we've got the limit as n goes to infinity, absolute value of k times k minus 1, and so forth, up to k minus, this will be the n plus 1, over n plus 1 factorial, and then x to the n plus 1. We're going to divide that by the nth term, so we'll go ahead and flip it and multiply by the reciprocal. So that reciprocal is going to have k minus 1, up to k minus n plus 1. This is going to be n factorial, and then we will have x to the n down here. So let's see what we can do to simplify this. We can cancel this and leave us just an n plus 1. This will leave us just an x with this. Now this k and all of these will cancel, and this will be the nth term, so that'll cancel with the 1 in front of this, but we will be left with this piece. If we distribute this through, the 1's will also cancel. So what we have left is, we can go ahead and put this x out in front, limit as n approaches infinity of, here we have k minus n over n plus 1. And for this to converge, we need this to be less than 1. So as we look at this, we have the absolute value of x, and then the limit as n goes to infinity of, if we multiply everything by 1 over n, we have k over n minus 1 over, put these absolute values on here, 1 plus 1 over n. Now as we let n go to infinity, because k is fixed, that's going to go to 0, that's going to go to 0, and we looks like we get a 1 here. So we need, when this is going to be less than 1, so we have our absolute value of x less than 1. So it looks like we've got a radius of convergence of 1 here. Now let's look at this, and the traditional notation for writing coefficients in a binomial series, they're called then the binomial coefficients, is we put this like this, and this is what it equals. And if k is a positive integer, so if this binomial is raised to a positive integer, then this will simply be computed by doing k factorial over n factorial times k minus n factorial. However, k doesn't have to be a positive integer, it could be something else, and then we would need to look at it in this form. Now make sure you watch some examples so you can see that when our k is a positive integer, it's just very similar to a binomial expansion like we learned in college algebra. But we now can express these when our k is not a positive integer. It could be a fraction, it could be a negative, and we'll have some examples that follow to show us this.